This video will walk you through all of the steps that you'll need to do in Microsoft Excel to complete your extra credit assignment, starting with getting your data from the assignment description. So you'll just click on the Biodata and Academic Performance Data link, open up that data in Excel, and the first thing that you want to do is save it. So do the File, Save As, and then just save it somewhere. I'm going to save it here. All right. So now I've got my data. Before we look at the assignment and go through it, I just want to break this data down for you a little bit. So this data represents some data that I collected from students using a survey that you'll see at the end of your assignment sheet. So the survey key is right here. So you'll see that there are 16 questions. And when you look at Excel, you'll see that there's 16 columns. Each column represents the question. So the first question, right there, financial support, you can look at the key at the end of your assignment and you'll see how much financial support do you receive from your parents or spouse. So the shortened version of the questions that I use to label the variables are in italics in the survey key at the end of the assignment, and the question number that precedes each question also precedes each variable name. Now you also may want to look at the numeric values assigned to each of the responses for each of the questions, because those are the numbers that you'll see in your data set. So in this question, 1 represents none, 2 little, 3 some, 4 a lot. So this first person responded as a 2 to the financial support question, which means they said a little bit. All right. Just want to show you how to use the key to interpret the data here. This next person rated themselves as a 1 on parents having a degree. Parents having a degree, so did your parents complete at least a 2-year college degree? And they said that neither parent completed a 2-year college degree. Now for the most part, the numeric values associated with all the responses represent higher numbers, mean more of whatever is being measured. So participation in social activities, larger numbers means more frequent participation. Studying, how often do you study with a group of fellow classmates? Larger numbers, more often studying with classmates. And you'll see that trend throughout all of these different variables in the survey. So if each column represents one question in the survey, each row represents one person. And getting rid of that first row, we have 43 participants in the survey. Okay, so this is all the data for these 43 NSC students. Now you know how to link each one of these columns to the variables represented in the survey. So let's go ahead and look at the actual assignment in Microsoft Word. And again, the survey key tells you all the questions and all the numbers assigned to all the responses at the end of the assignment. Make sure that you read all these directions thoroughly. They'll cover some of the stuff in this video, but there's some extra stuff in here that you need to understand. All right. One of the major things, make sure that you keep all of your work that you do in Excel and submit that along with the actual filled in assignment here. So the first step is conducting a correlation analysis in Excel, and we're going to be using the biodata questions, which represents all of these guys right here, all of the biographical pieces of information from the survey, the biodata. That will be our independent variables, and then the dependent variable will be GPA in this case. Now your assignment, the dependent variable, is the number of FDs and withdrawals. So I'm going to show you everything that you need to do in Excel. The only difference is that I'm going to be using a different dependent variable. I'm not just going to give you the answers in this video because it is an extra credit assignment, and I want you to go back and do the analyses using the other dependent variable in this case. So I'm looking at GPA as a measure of academic success. You will be looking at the number of FDs and withdrawals. Okay, so for GPA, we want to conduct the correlation analysis looking at all of the predictors of GPA. And as you'll see up here, The rationale for those questions is mentioned up here. Just based on past research, the biographical information that tends to be linked with academic success is what the data collected, or the survey collected data for. Okay, correlation analysis. Now, before you can do a correlation analysis in Excel, you need to activate the Data Analysis Toolpak. It's a default setting in Microsoft Excel 2010, and you will be able to activate it for free. That being said, if you do not have Microsoft Excel 2010, you may want to do all of these analyses from NSC. The computers on campus are equipped with that version of Excel. Now, these capabilities are in newer and older versions of Excel, but it may not look identical. So if you're not really comfortable with using Excel, you probably want to use the exact same version that I'm using. So to get the Data Analysis tab, you click File, go down to Options, click Add-ins. Make sure the Analysis Toolpak is selected from the add-ins list. Click Go. Make sure there's a little check next to Analysis Toolpak, and then simply click OK. Now when you click on the Data tab, you'll see a Data Analysis feature. So we're going to do a correlation using Data Analysis. So select Correlation, click OK. Now we need to select the input range, so all the variables that we are interested in. So the easiest way to do this is to start at the first label for the first variable in our data set. Hold down, so scroll down to the last person's response for the last variable in the data set. For you, you're going to click here. For me, I'm just going to GPA. I'm going to ignore FDW, fail D withdrawal. Hold down the Shift key and left click right there. That selects all of that data. You can also click and hold down and drag, but that holding down the Shift key, going from the very top to the very bottom, is a lot easier. Then make sure that you have labels in first row checked. That's telling Excel that the first row that you selected includes the labels for the data. Then next to the new worksheet, let's go ahead and put correlation. All right, click OK. Now don't be overwhelmed by all these numbers because you're only going to be really looking at this row. But I do want to interpret some of these for you just to give you a basis of understanding. First things first, let's go ahead and widen all of these rows or columns so we can see the full variable label. So right in between A and B, just double click. B and C, double click. So you'll see that little double-sided arrow. When that appears in between each column, you can double click with the left click, and it'll expand the column to match the contents. So I'm just going to do that for all of these columns. Now you'll start to see that as I get further and further out, the variables in the first column have disappeared. But there's a way that you can keep those visible. So if you go to View, select Freeze Panes, and then freeze first column, no matter where I go, I still have that first column visible. And that's important because when you go to look for the correlation coefficients between two variables, you need to find where the two variables meet, judging by the first column and then along these different, or the first column and each row and then all these columns. So this first one, financial support and financial support, it's the exact same variable, so of course it has a perfect correlation. We don't really care about these ones here. We know that the variable is perfectly correlated with itself. The next one, this is the correlation coefficient between parents having a degree and financial support. It's where these two meet. This is the correlation between parents having a degree and social activities on campus. Let's go ahead and interpret this first one that we're looking at here. So remember, the way that the numbers were assigned to the responses in the survey, higher number means more of whatever we're measuring, whatever we're looking at. And remember from the overview of correlation, a positive value, so this isn't negative, this is negative, this isn't negative. Positive value means that as X increases, Y tends to increase, or they're changing in the same direction. So what this tells us in plain English is that students who have more financial support tend to have parents that completed degrees. So more parents that completed degree tends to be related to more financial support if you stated it the other way. Tend to is a key word there, right? Just because we have a correlation doesn't mean that there's a causal relationship. And in fact, if you look at the assignment, so we've done the correlation analysis, I tell you that for a correlation to be significant, it has to have an absolute value of 0.25 or above. So we're ignoring negatives. Remember, we're just looking at the strength to figure out if it's significant. Doesn't matter if it's negative or positive. Then we say that the correlation is significant, meaning that there's a really high chance that there's a true relationship between those variables in the population. So if we go back and we look at this, this is actually greater than 0.25. So we would say there's a significant positive relationship between financial support and parents having a degree. Putting that into plain English, which you'll see there's a plain English piece of this assignment. Get rid of the answers. We'll find those in a second. Putting that in plain English, students who have more parents that obtain a college degree tend to receive more financial support. And if you need to see what those variables are measuring, the survey's right here. Parents completing at least a 2-year college degree, financial support. That's what those variables are looking at. So that's not one of the variables I'm interested in you looking at for the assignment, because really all I care about are what independent variables, which pieces of biodata are related to GPA, GPA being our dependent variable. But if you want to go through and look and see what's significant among all the independent variables, be my guest. It's pretty interesting. So again, for it to be significant, it needs to have an absolute value of at least 0.25. That's something that's called a critical value. And I looked that up in a table, but I'm not going to expect you to know how to do that. Just looking 0.25 or above. So go back to our data. Let's look for all the correlations that have an absolute value of at least 0.25. So GPA and financial support, not significant. It's not at least 0.25. GPA and parents' degree, not significant. GPA and social activities, not significant. GPA and group study, not significant. GPA and missed classes, significant. So let's go ahead and mark that in some way. So I'm going to go over here to the Home tab, and I'm going to highlight it. GPA and number of semesters at NSC is significant, so I'm going to go ahead and highlight that. GPA and semesters at CSN, not significant. GPA and semesters at another college or university, not significant. Scroll over. See why it's important to have that still visible. GPA and number of children, not significant. GPA and caring for loved ones, not significant. GPA and annual household income, that's greater than the absolute value of 0.25. GPA and how many miles away you live, not significant. GPA and hours worked, not significant. And then GPA and the typical number of credit hours is not significant. So out of all those biodata predictors, only 3 have a significant relationship with GPA. So if I were to explain these in plain English, I would say, okay, this is a significant negative correlation. So in plain English, those who miss more classes tend to have a lower GPA. Changing in opposite directions, right? More missed classes, lower GPA. Using the word tend to emphasize that this isn't causal, it's just a relationship. Next one, those who tend to take more semesters, or those who have taken more semesters at NSC tend to have a higher GPA because this is a positive significant relationship. And then finally, those who have a higher household income tend to have a higher GPA, significant positive relationship changing in the same direction. So I'm going to go ahead and write down number 5, missed classes, and then number 6, semesters at NSC, and then 11, annual household income. So that I can put those into my assignment. Which piece of biodata have a significant relationship with GPA? Well, number of missed classes. Ooh, that's very, very large. Let's not do all caps. Number of missed classes. Number of semesters at NSC, and then annual household income. And do me a huge favor, you can highlight your answers, click B or hit Control B to bold them so I can find them easily. Now explaining what these correlations indicate in plain English, I already did that. Remember, those who miss more classes tend to have a lower GPA. Those who have been attending NSC for more semesters tend to have a higher GPA. Those who have a higher household income tend to have a higher GPA. Granted, yours are going to be a little bit different because you're looking at a different dependent variable, but the strategy is still the same. I'm not going to write it out just to save time. Okay, now we're going to do something called a multiple regression analysis, which you learned about in the previous section of this video. So we're going to use these variables that have a significant relationship with GPA to make predictions of what we think the GPA would be based on the particular levels of these biodata. So first of all, we need to edit our data a little bit. So let's go ahead and go back to the biodata survey, right click, right there on that tab, go up to move or copy, select create a copy, then click OK. So I'm going to be deleting some variables. I'm going to basically delete all the pieces of biodata that are not significant related to GPA. But I don't like to just delete data willy-nilly. I might want to go back to it later. So it's important that you just make a copy and you do edits to the copy. So I only want to keep number 5, missed classes, number 6, number of semesters in NSC, and number 11, annual household income, and then of course GPA. So I'm going to get rid of, so right click and then just drag over 1 through 4. Then I'm going to just hit Control and get rid of 7, 8, 9, and 10, and get rid of 12, 13, 14. I'm going to go ahead and get rid of FDW too because I'm not looking at that in this example. Then right click in any of these blue sections, click Delete, and those are gone. They're still in the original data set, but they're gone from the data set that we're going to be working with for the regression analysis. And for some reason, Excel will not let you do a regression analysis unless you're using all the variables in your data set. So we're going to delete them so that Excel will permit this regression analysis. Another thing I want to point out is that Excel will not permit you to do a regression analysis when there's missing data. So there was actually a few more people who responded to the survey, but they didn't complete all of the questions. There was missing data, so I got rid of them from the analysis because Excel won't let you do regression with missing data. Okay. So now let's go back to the Data Analysis tab, click Data Analysis, and let's go down and do our regression. So click Regression, click OK. Input Y range. Y variable is our dependent variable. Remember, the regression equation is all about making predictions about Y, and Y is our dependent variable. Because we're thinking that our dependent variable depends on the predictors, the independent variables. So that makes sense. Independent or input Y range. So you can have this box clicked and then you can just select all of these. Just click and drag. You could have also clicked up here, clicked down here while holding shift. Or if you're a little sketchy about, oh, am I in the right box? You can click this little grid next to it and just select all of that and then click it again. Then our X range, that is all of our independent variables. So I'll click this, click here, and just highlight all of our independent variables. Click it again. Just like the correlation analysis, you want to make sure that the labels box is checked so Excel knows that the top row represents the labels. And then let's put this in a new worksheet called Regression. And click OK. Now let's go ahead and do the double click strategy up here with the double-sided arrow so that all of our columns are wide enough to fit the contents of each cell within it. All right. Don't be alarmed by this output. We're really only going to be looking at this and this here. And sometimes if you see error values, you can get rid of those by highlighting your numbers, right click, go to Format Cells, Number, and let's go ahead and do 3 decimal places and click OK. So if you look at your assignment, the first thing that you're asked to do with this output is figure out which predictors are significant in the regression equation. Now, I don't give you a critical value of what the value for the particular B has to be or what the coefficient has to be. I give you a different way to look at this. So for regression, Excel gives you a significance value. And basically, if we look at this p-value, this is the significance value. P stands for the probability that there's not a true relationship between those variables in the population, between this and what we predicted, which was GPA. And the criteria for that is that the p-value has to be less than 0.05, meaning that there's less than a 5% chance, because if you take 0.05 probability, multiply it by 100, it gives you the percent chance. So p less than 0.05, meaning that there has to be less than a 5% chance that the relationship between the two variables we're looking at is just due to random chance. So just looking at this, to keep it simple, and it's stated for you here, look for predictors with a sig less than 0.05. This is the p-value, significance. I'll just change that to p so that, right there, p-value. P-value. All right. Less than 0.05, meaning if there's less than a 5% chance that the relationship is due to error, then that means there's at least a 95% chance that there's a true relationship between those variables in the population. And I also tell you here, to find the exact percent chance there's a true relationship, you can take 1 minus let's change that to p-value, multiply it by 100. So for example, what is the percent chance that the relationship between missed classes and GPA is actually due to a true relationship? So I can do 1 minus 0.003, that's my p-value, equals times 100. There's a 99.7% chance that there's a true relationship between missed classes and GPA, and that we should be confident in missed classes being a predictor for a GPA. Just a quick little side note there. For your purposes, look for p-values less than 0.05. And the intercept, don't worry about that. Only look at your p-values for your independent variables. So the p-value for missed classes is less than 0.05. The p-value for number of semesters at NSC is not, and the p-value for annual household income is. Now, remember in the lecture earlier, I said that the multiple regression looks at how 1x predicts y after controlling for the other x values in the data set. So sometimes when there's just a relationship between x and y, once you plug multiple x's into the regression equation, some of those predictors or independent variables no longer are significantly predicting or related to y. So what this basically says, this is no longer significant. And that's probably because the number of semesters at NSC is related to missed classes and annual household income in a way that once you control for these, the relationship between semesters at NSC and GPA becomes non-significant. Also, this is beyond what you need to know, but just because I'm a statistician, we're trying to see which variables predict differences in GPA. Well, maybe so much of the differences are being predicted by missed classes and annual household income, there's not enough differences left to be predicted by the semesters at NSC. So these are stronger predictors of differences in GPA compared to this. So if you look at your assignment, which predictors are significant in the regression equation? Well, for this, missed classes and annual household income. So I'm just going to steal that from here. Number of missed classes, control, highlight, control C. Those are the only two that are significant. So now I want you to run another regression analysis only looking at the significant predictors. And this needs to be GPA for me. GPA. Okay. So now let's run a multiple regression analysis just looking at number of missed classes and annual household income. So let's go back. Let's go to our biodata survey here. The copy, not the original. And let's go ahead and get rid of the number of semesters at NSC. Right click, delete. And let's rerun the regression analysis. Data analysis, make sure the data tab is selected. Data analysis, regression, double click. Our Y range has moved now, so we can click on this, reselect our GPA here. Yours will be FDW. Then X range, click here, go here, select all the values, and I was holding Shift to highlight all that for our independent variables. Now let's label this new worksheet Regression 2. Excel won't allow you to name the same or two worksheets the same thing. So, all right. Now let's go ahead and fix our variables here. Let's highlight, right click, format cells, number, 3 decimal places, and then click OK. And let's go ahead and stretch that out. All right. So both of these are significant. We knew that was going to happen. And now we have these coefficients. This is really the only thing that you need to look at once we realize they're significant to write the regression equation for these significant predictors. So remember, the regression equation is equal to y hat equals bx plus a. Well, for our purposes, we're going to have 2 b's and 2 x's, right? Because we've got multiple x's. We've got 2 x's. So b, those are, in your Excel output, the coefficients associated with its respective independent variable. A is your intercept. Another word for the constant, the A, is the y-intercept. It's where the x and y axis meet. Or no, sorry, it's the value for y where the x-axis meets the... So if you've taken algebra, you'll remember, mx plus b, and b was the intercept in that case. But for some reason in statistics, it's bx plus a, and a represents the intercept. So this is the end of that regression equation. This would be the A. These are your B's for each one. So let's go ahead and write that regression equation. So y hat equals, and actually I don't want you to have to go and do insert symbols and try to find y hat. We can just put predicted, for mine, GPA equals, all right, so the first missed classes, negative 0.625. Negative 0.625 times number of missed classes plus, let's go back, 0.204 times, and I think that was annual household income. Yes. Annual household income plus that constant, that intercept, 10.875. Okay, so I'm looking at this. And keep in mind, there for a second I was like 10.875, but if you go back and you look at how GPA was coded, 10.875 would be somewhere between 10 and 11. Now, for your purposes, the number is going to be more straightforward. Now, the reason that I did this and didn't just say what's your current GPA is because it's kind of a pain to clean data when people will write, I don't know, maybe a 5. They don't just give me a raw number, so I was actually being lazy there. But if I wanted to be a better statistician, I would have asked you to just type in GPA or ask the participants to just type in GPA. All right. So the interpretation of this is going to be somewhat funky, but not for you guys. All right. This is my regression equation. Hooray! I've got each b times its respective x plus my coefficient for my intercept. All right. So now use a regression equation to predict the GPA for someone like you. So I actually did complete this survey, and I was using my experience at Washington State University as a reference. So let's see, I'm going to copy this, Control C, Control V. Number of missed classes. So if I go back here and I look for the number of missed classes variable, which is number 5, I'm not going to brag, but I pretty much missed 0 classes. So my value would be a 1 for that. So I'm going to plug in a 1 here. And then my annual household income when I was in graduate school, let's go down and look. So that was number 11. I was making about between 30 and 39 household income. So 4. So replace that placeholder for annual household income with a 4. Now I'm going to do the math to see what my predicted GPA range would be. So I'll get my calculator out. Negative 0.625. Well, that's easy. Times 1, it's going to be negative 0.625. Negative 0.625 plus 0.204 times 4, 0.816 plus 10.875. Now before I complete this, just to break it down, this is saying up here that for each additional missed class, you would expect your rating on GPA to decrease by negative 0.625, keeping in mind that it's numeric values in the data set, not your all GPA. For each additional ranking in household income, you would expect your GPA to increase by 0.204 points in this metric, right? The metric that I assigned to it. And that regardless of your number of missed classes and annual household income, you'd be about a 10.875, so pretty close to an 11 on your GPA. So around, a little below 3.25. Okay, just to give you the concepts behind that. So let's do the math. Negative 0.625 plus 0.816 plus 10.875 gives me 11.006, which would put me right at, let's see, I'm just going to copy this, Control copy, Control C, and I am right around there. I'm just going to put a little arrow. All right. So based on this regression equation, it predicts that my GPA would be between a 3.25 and a 3.49 because that 11 was assigned to that range. That's pretty accurate for me. So I'll say yes, it is pretty accurate. I'll say accurate. I'm really liking the caps. My GPA in grad school was a 3.65. So, pretty close. It's not perfect. It underestimated me, but that's to be expected because the correlations weren't perfect between each of these X values and the Y value. So I did this for a reason, and I'm going to follow my own rules here. I'm going to bold these. I really think that it's useful to know how to use regression analysis, and it's something that we didn't cover in class that I think is really has a lot of practical application for you guys. So I hope that in addition to getting some extra credit, that you found this to be really useful, and you can use this video as a reference in the future if you're ever trying to make predictions based on data that you've collected.